ആ കേബിൾ പുഷ് ചെയ്യാൻ മതി.
So for the past 1 year, I was giving lectures to the public regarding the ill effects as well as the benefits of plastics. So every time I end up with a question from the audience that if this is this much of poisonous substances are contained in it, then why can't we have a solution? At least we can ban this hazardous substance. But that is not a solution. Because it is having many beneficial things also. So we thought of having a new technology to process this plastic, which is treated as a nuisance to the society. We are having conventional technology as well as modern technology for the recycling of plastic, for the conversion of plastic. And the main thing which we are doing in the conventional technique is either we can recycle it, or we can incinerate it, or we can use it as a landfill. But this will not solve the problem because it is giving a lot of carcinogenic materials, I mean dioxin, furan. If you are incinerating them, it will be emitted to the environment. And if you are simply using it as a landfill, then many of the valuable chemicals which we are adding there to improve the quality of plastic, that will be lost. And moreover, plants also cannot survive in the field where we are going to landfill the thing. So the fertile land, that will be converted to a desert place. So this will not be effective. So in the modern technology, what people are doing is they are using plastic widely for the construction of roads. And there the temperature they are having is maximum up to 180 degrees centigrade. And in another phase, what we have observed is they are using it as a copolymer or a co-processor in cement kilns. And there the temperature, it can go up to 300 degrees centigrade. And the other technology which is in practice, it is plastic fuel technology. In the first two processes which I mentioned for a road construction as well as for a cement kiln, where plastic is heated in the presence of oxygen, again it is toxic to the workers who is working in that field, so it is not advisable. So the next leftover option is plastic to fuel technology. US, Korea, China, and in India also we are having a plastic fuel technology. In Nagapur, Dr. Alka is after that. And I have noticed that in all these countries, they are converting plastic directly to the crude oil. But in the crude oil process, all the valuable chemicals are also demolished. That is also burned off. They are simply cooked off. So we don't wanted that. So what we have done is we have modified the technology to that level that all the plasticizers which were added, that can be retrieved, and the left out thing is gas, which is high butane, which is the same content which is present in liquefied petroleum gas. So what we have done is we have made the plastic clean, and we have made it in the dry form. We made it to the fine powder stage or to the pea stage. And in the absence of air, we have modified the environment and we decompose the plastic. And wherein what we have observed is all what is there added as plasticizer, that can be converted or that can be retrieved fully from the fully through the process, and the remaining one which is emerging out, which will be rich in hydrocarbon, lower hydrocarbon, and which will be functioning as a gas. And it is equivalent to butane, which is the main ingredient which is there in a liquefied petroleum gas. This technology, it is a totally new technology, wherein this is the first method in world where plastic is totally converted to fuel from assorted plastic. That means all types of plastic we can use it safely without the emission of any type of poisonous gases. And thereby this method, it's a profitable method as well as an eco-friendly solution for energy production, which we feel. Then we have used all categories. I mean, we are having number codes from 1 to 7 for plastics, and all those plastics we have used, including PVC. PVC, it is a polyvinyl chloride, which is the most hazardous substance, which is considered as plastic poison. Even plastic in a safe mode we could process, but the only thing is that in the very same process PVC should be treated separately, not along with the other plastics. So one day we have to keep this plant exclusively operational for PVC. The rest of the days, all the other plastics in an assorted way we can use. And initially we need some temperature, and that temperature we can either generate from the gas which we can divert the gas to some extent, or else we can have a biogas plant side by side, so that the energy from the biogas that can be used for the heating purpose. And the main highlight is that all the chemicals which we are adding for the preparation of plastics for enhancing the properties, all those things that can be retrieved and can be marketed. So this plastic, which is considered as a waste, it is no more a waste, it is an energy source as well as it's a source of revenue. Okay. And, 4 grams of plastic, it was giving us 750 milliliter of gas, and thereby we can calculate always the gas that will be expressed in cubic feet of gas. So in an LPG cylinder which is 14.2 kilograms, which has 2030 cubic feet of gas. So if you are getting 750 ml from 4 grams, we will be getting from 1 ton gas equivalent to 3.4 cylinders. And the plastic, the NIT, it is located in Calicut Corporation, and Calicut Corporation, we have 300 tons of plastic per day. So we will be in a position to have 1020 cylinders generated from this method. And the plastic needed for having one cylinder of 14.2 kilograms, it is equivalent to 292.5 kilograms. ഇതൊന്ന് പിന്നെ എന്താ അതൊന്ന് പിന്നെ ഹീറ്റായി ഇതായി വരാം.
National Retail.
this can be fine carbon, and this carbon can be made activated. So we are treating it chemically.
Okay.
So that activated carbon can also be the part of this.